So now we're gonna check something called Boole's algebra. Boole's algebra can be broadly defined as a set of operations and expressions that are used with Boolean variables. But you're gonna tell me what's a Boolean variable? It's nothing more than these things that you've already checked, and like things that can get two values that are zero or ones. Okay, pretty much. And for sure, I know that you have checked these operations. The system of them all, well, there are three. They are called AND, they are called OR, and they are called NOT. Okay? And pretty much there are truth tables that describe their behavior, and we're gonna write it right now. Okay? So let me write them here. We're gonna have two variables. Most of the time, we're gonna start with like the first three or four letters of the alphabet, or the last three or four. That means A, B, or C, or W, X, Y, and Z. Okay, so just for you to be comfortable with this, those mostly are like the inputs and the outputs. Okay, so let's say we have two variables, A and B, and we have to make a small table that describes the behavior of the AND gate. Okay, these are the four values that the variables can have. All the possible combinations are written in this truth table. Okay, and we're gonna start with the AND. The AND gate can also be represented with a little ampersand, two of them, or this little funny symbol, depending on which one you like, or you can write AND. All of them are valid. Well, AND works whenever A and B have the same value and that value has something. Okay, so unless both of them are ones, the rest of them are gonna be zero. That is 0, 0, 0 here, and 1, 1 over here. So once again, they're just like those fancy guys that unless both of them are true, the result is true. Otherwise, you get like a zero. Now you can represent it actually with this cool symbol. It's just like a little nutshell or a little D, as you want to see it. That's this thing. Okay, this is the diagram of an AND. So you get an input A and you get an input B. Okay, that's pretty much the AND. Let's go with the second one, well, the next one, and that's called an OR. Let me keep on writing A, input B, and the OR right over here. It's gonna be here. Let me trace another line over here, and well, all the combinations. This here it is 0, 0, 1, 1, and well, basically the OR gate allows you to well, whenever you get a value in either variables of the input, you're gonna get a 1. Okay, so the only value that you're gonna get a 0 is the first one. Okay, because you get into the second line and you say either one or the other one is true. Okay, I got a true here in B. The next one I got a true in A, and the last one I got a true in both of them. Okay, so pretty much there are them. Okay, and the funny symbol for OR is like very similar to the AND, but you can see it like a little arrow. There you go, there you go, and you can write a little plus in the middle. That's the way you know it's an OR. Once again, it has two inputs, A and B. Okay, so I think we're doing well for now. Well, let's keep on the good work, and we're just missing one extra gate. That's called the NOT, also called the inverter. Well, OR is written with two pipes most of the time, and NOT can be written in several ways, like this funny symbol or just an exclamation mark. Okay, so let me just write the truth table. This one is actually very easy, and it's called an inverter because it changes the value of one thing to the other one. So you only have one input, and the truth table is very, very small, and you're gonna get the NOT here and two values. Okay, so if it's 0, you get a 1. If it's 1, you get a 0. Okay, and the value for this thing is just a little wire, you like a little triangle, and at the end of it, you just write a little circle. You get the A, and then you get the NOT. Okay, This little apostrophe is the way of writing it. Let me start blowing some heads here. Or it's gonna be written this way. And finally, the end is gonna be written this way. In a way, you can make like an analogy. It's not that easy to see, but well, the and can be seen as a multiplication. Why is that? Because 0 plus times 0 is 0, 0 times 1 is 0, 1 times 0 is 0, and only 1 times 1 gives a 1, okay? So this guy can be seen as a multiplication. The OR can be seen as an addition, because 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1, well, I know that could be 2, but yeah, I still have a result different than 0, so I'll write a 1, okay? So this one can be seen as an addition, and well, the inverter, I think you don't have like that much problems into knowing what does it do. I know this video was too long, but I promise things will get better in the next slide, okay?